Okay, this lecture is solely for your assignment, and everything you need to do your assignment is contained within it. So, without further ado, let's get started. All right, so key thing is that there's many different kinds of light, and lots of them are absorbed by the atmosphere, and lots of them are not absorbed by things that absorb visible light. Here you see an infrared picture, and notice that the glasses block the infrared light, but the infrared light goes straight through the trash bag, which normally wouldn't let visible light pass through it at all. This affects how we have to build telescopes and other observational things because the atmosphere of planets can block lots of different kinds of light that astronomers are interested in. For example, our atmosphere blocks, starting far from the left at the most energetic type of light, our atmosphere blocks gamma rays and X rays and ultraviolet light. It does not block visible light, which is the kind we can see. So lots and lots of telescopes work on visible light. It blocks most infrared light. It blocks most forms of microwave light. It does let radio signals through, and so there's lots and lots of radio telescopes on the planet. But to detect gamma rays, X rays, ultraviolet, and most infrared and most microwave, if you want to see it, you gotta put something in orbit. That's why there's so many telescopes out there in orbit around the planet. I'm not going to do apparent magnitude activities today because it's not relevant to this assignment. Here's an image of a radio telescope. This thing in the center is just a little galaxy, and the jets coming out either side, remember I told you you'd see a lot of accretion disks, is energy shooting out of the top and the bottom of the accretion disk. And it's huge. So this galaxy just had a big meal, and it shot out jets to the top and the bottom, and those jets are impacting the space in between galaxies and creating a huge shock wave. In between galaxies is not completely empty. There's enough stuff out there to make a shock wave. Here's an example of a radio telescope. They're huge, they're dishes, therefore absorbing a lot of radio light, and then the dish bounces the radio light up to the receiver at the top. Here's more radio telescopes. These ones are close to microwave sensitive, but not quite all the way there. It's still within the visible window for the planet Earth. And here is a whole bunch of radio telescopes, all of which can talk to each other and coordinate information. More about that later in the course. Here's the largest radio telescope in the world, Arecibo. It got a lot of damage during Hurricane Katrina. FEMA used it as a base of operations to work on restoring the rest of the island. And then recently, the dish completely collapsed. So Arecibo was probably out of commission for good. It was a really interesting telescope, though, because it was the only telescope we had that could both detect radio waves and also shoot out radar. And so by shooting out radar, we could take that emitter at the top, send out a radar pulse, send it somewhere in the solar system, and then it would bounce off the object, come back to Arecibo, and we'd know exactly how far away the object is. So it was a real resource, and it's a pity that now it's completely broken. Sometimes you don't have to get in orbit. Sometimes we put telescopes in planes and we just fly them super high. And so that works as a technique sometimes. And then infrared light can let you see through dust. I'm going to show you these two images when I come back and do this lecture more formally. And radio telescopes and visible telescopes can see quite far away. This is a visible telescope picture from the Hubble Space Telescope. So almost every dot you see is a galaxy. And the amount of space this takes up in the sky is the amount of space that would be covered by a grain of sand held in your hand at arm's length. So it is quite a lot of galaxies covering a very small space. And from pictures like this, we extrapolate how many galaxies are visible to us in the universe. And the answer is it's a lot of galaxies. Here is one of our X ray telescopes. All X ray telescopes have to be in orbit. And here's a telescope that we mean to launch and we meant to launch for over 10 years that's going to be super sensitive to infrared radiation. So sensitive, in fact, that we're going to put it on the far side of the moon, where the sun can't touch it at all. And then here's a picture of what the newest telescope we're going to make looks like, the European Extremely Large Telescope, because astronomers are not good at naming things. Now, not everything we do to check out other planets depends on telescopes. Sometimes we send probes out. Here's a picture of the path that the Voyager 1 and Voyager 2 took. Voyager 1 just visited Jupiter and Saturn, and then it went out into the solar system, and then away from the solar system.
Daddy, I have about just what you do.
I know, it's so great. Hold on. Good belt.
Daddy, can you turn on the light?
Yes. Sorry about that. I'm a single parent, but I'm going to try to record the rest of my lectures from Cal so as to avoid that. My kids are just visiting for quite a long time, and so I've had to adjust. Okay. Um, right. Whereas Voyager 2 was launched a little later, and in its launch window, we were able to calculate a path for it that goes by Jupiter, by Saturn, by Uranus, and by Neptune. It's still the latest probe that's visited Uranus and Neptune, and its instrumentation was not particularly sophisticated. So we got some grainy pictures of Uranus and Neptune, and that's about it. A new mission to go out there and check them out will be very welcome by astronomers. We have, however, sent a new probe out to Pluto. Up there, top left is Pluto. Bottom right is its moon, Charon. Although Charon is so big in comparison to Pluto that. Oh, great. I will help you.
I got my bells off.
Although Charon's so big, you might as well consider it a companion planet instead of a moon. Because Pluto and Charon's only about a third of the size of Pluto. And sometimes we send rovers, mainly to Mars, although occasionally to the moon. China just got one there. And here is 3 generations of Mars rovers. One more has since landed, and
Daddy, can I have kids done?
yes. Okay, and we're back. So there's the rovers that have gone to Mars. Here's a little selfie that one of them took. This is an excellent video about the Apollo mission, which is the only time that humans have left the planet and come back. So I highly recommend watching it. It's great. It shows you how the whole thing worked and how the capsule worked and the return capsule worked and how the splash landing happened and how they actually landed on the moon. There's some more pictures of Apollo and the rocks they brought back. This is how we know that the moon used to be part of the Earth's crust, through being able to do radio dating on the rocks. And then we're not going to do Planet of the Day yet because I am going to come back and do this lecture in more detail. Thanks. Have fun with the assignment. I will record another lecture when I'm back from camping. Ciao.